The world has grown hyper-hygienic since the pandemic, with plastic playing a prominent role. Face masks are one of the items we know of that can help stop COVID-19 from spreading. They come in various sizes and forms, and many are disposable.
Face masks have become essential for staying safe during a pandemic. According to a study by the American Chemical Society in 2020, 129 billion are used worldwide every month, with 3 million discarded every minute.
Most face masks are constructed of layers of plastic microfibers that, if mishandled, can become hazardous to the environment. Thus, we, the researchers, proposed the study. Faespher, a face mask scrap-produced paper. I am Aaron Jure D. Yumol.
I am Ana Gabriel Donaire.
And I am John Raven D. Alyanige. Welcome to our presentation.
The buildup of face mask waste that carries environmental toxins adds to the destruction of our beloved Mother Nature. Because of this, we are looking for strategies to assist in the waste management and recycling of plastic, mainly for disposable face masks. Our study has 3 primary purposes. First is to utilize the scraps from face mask production. Next is to recycle these unutilized scraps into a functional product. And last but not the least is to find an alternative material in making paper to save the environment in terms of improving plastic pollution. Hence, this study will formulate a product with high practicality characteristics and solve an environmental issue.
Furthermore, this study will be utilizing the IPO model, a 3-part computer concept: input, process, and output, that is to be used to systematically evaluate the procedures that will be present in the manufacturing of the face mask scrap-produced paper. First, with the statements of the problem already formulated and approval to conduct the study, the researchers procured the materials needed for the project. Next, the gathered scraps of face masks were disinfected. It was then followed by fragmentation of the face mask scraps. For the 4th step, the calcium, stone, and face mask scraps were mixed. After that, the mixture was heated and rolled. Soon after, rigorous testing for the paper followed. Lastly, commercial production served as the final step.
There are 3 primary goals or objectives for this study. First, to repurpose scrap face mask waste as an ingredient in paper making. Second, to compare the quality of regular commercial paper to face mask scrap-produced paper. And third, to provide further information regarding the possible utilization of single-use face masks.
While conducting this study, we will use these questions to guide us toward our objectives. Number 1. Can face mask scrap be a raw material for the commercial production of pulp and paper? 2. How can the quality of face mask scrap-produced paper be described? And number 3. What is the difference between regular and face mask scrap-produced paper?
In collaboration, we have made an educated guess that the chemical properties of scrap face masks shows a significant potential to be a raw material for pulp and paper production.
Our study focuses on producing paper from face mask scraps, which can provide knowledge in controlling the amount of face mask waste in the future. We will exclusively use scrap from disposable surgical face mask manufacturers that will be used as the material for paper making. This study will not include face masks such as cloth masks and N95 masks.
Furthermore, the study will be confined to the following tests to determine the specific features of the final product: ISO 1974, ISO 536, ISO 534, ISO 1924, ISO 2758, and ISO 5626. This will be further elaborated in the methodology section by yours truly.
For the safety of the researchers and the recipient of the product, the researchers will not conduct the study using used surgical face masks. As a further matter, This study was delimited solely to provide information for future purposes and not claim that the product produced will serve as an answer to the pollution produced by face mask waste.
The data to be produced from the research study may provide an in-depth analysis of the chemical properties of face masks. Furthermore, the study will be significant to the following beneficiaries: us, the researchers, face mask manufacturers, fellow researchers, and consumers. Apart from this, a percentage of the profit will proceed to our chosen beneficiaries.
A true experimental research design will be utilized in the creation of this study, which is defined as a method of research that incorporates a researcher-manipulated variable as well as variables that can be measured, calculated, and compared to analyze a hypothesis using quantifiable data.
Because of its prevalent use and contribution to the significant increase in pollution, we will use the face mask scraps as the study's sample and component of the paper product.
Of course, to make the product, the following are the instruments that are going to be used during the process of paper making with face mask scraps. For the disinfection procedure, we will need our sample face mask scraps, 95% ethyl alcohol, disinfectant such as Clorox or bleach, and a rectangular metal strainer to separate the face mask scraps into solvents.
For the fragmentation procedure, we will be using water, sodium hydroxide, a disintegrator or grinder to tear the face masks into smaller pieces, and the hand sheet forming mold to form the shape of the paper. A beater and the Canadian free tester will be used in the beating procedure. In the rolling procedure, we will be using filter paper, a hydraulic press to separate the rest of the solvents from the paper and the mold. In the testing phase, Elmendorf tear test, digital analytical balance, digital thickness tester, and bursting strength machine will be used.
To acquire the appropriate sample face mask scraps for paper making, we will be seeking help from the following institutions: Medtech International Corporation Limited and Chemical Philippines Incorporated in Makati, Metro Manila. The final product will also be valuable to institutions currently having paper shortages, such as public schools for the teachers and students.
To attain the end goal product, the significant steps to be done in this study are the following. Step 1. Procurement of materials. Before constructing the product, the researchers will first identify the products and services needed together with the expenses. In addition, the strings of the face masks will be cut since the part that filters the airways will be the only part of the face masks to be used. The second step is the disinfection of face masks. The collected strap face mask from the supplier will be disinfected using ethyl alcohol and bleach. This is done to avoid contamination from the virus even if the masks are not used.
Step 3. Fragmentation of face masks. The face masks will be soaked in a metal container with 1 liter of water. Adding to the solutions are 30 grams of sodium hydroxide diluted to 400 milliliters of water. The face mask will be submerged for 5 hours at room temperature until they become soft and easy to tear. After 5 hours, the face mask will be drained using a metal strainer. Fourth step. Mixture of materials. The drained face mask will be mixed with calcium and stone to harden the product. The hardness and consistency will depend on the desired thickness of the paper. Step 5. Beating. For 10 minutes, the mixture will be put on the beater to refine the length. To test the water absorption rate of the aqueous solution, the Canadian free tester will be used by combining 800 milliliters of the mixture and 200 milliliters of cold water under 23 degrees Celsius. This testing is under ISO 5267-2 of 1999. Step 6. Rolling. Each container will have 500 milliliters of the mixture pressed on 3 filter papers to mold the paper. After that, the filter paper and the mixture will be put under hydraulic press to make it compact and flat.
Paper testing is during the 7th step, where we use the Department of Science and Technology recommended tests to assess papers in 2013. ISO 1974. This testing method will be used to determine the tear resistance of the paper. The Elmendorf method will be utilized in this stair test. ISO 536. The product shall follow a certain weight, size, and thickness. Thus, the paper to be tested must have fixed characteristics based on a standard paper. To determine the paper's thickness, density, and specific volume, ISO 534 will be used. Two phases will be done here, namely, measurement of the single sheet thickness and measurement of the bulking thickness. Next is ISO 1924. This test will determine the paper's tensile strength or stretchability using an instrument that measures the constant rate of elongation. For ISO 2758, this will determine the paper's bursting strength. A hydraulic press will be used. And in ISO 5626, the folding endurance of paper will be assessed in a longitudinal direction back and forth until it breaks.
For our 8th and final step, commercial production. The product will be cut in a short bond paper size, 8.5 inches by 11 inches, and bundled by 20s. After, the final product will be distributed to the institutions or companies looking for a paper manufacturer.
For the analyzation of the data, the final product will be tested by its strength, thickness, density, and folding resistance. The chemical and mechanical composition of the paper will be tested in the Department of Science and Technology laboratory to know its different properties.
During all this, we assure you that no animals will be used in this experimental research. Also, the face mask scraps used in this study will be tested for pathogens using an agar solution to guarantee the safety of our future consumers as well as our own.
Faespher is an all-purpose paper made not just to reduce the waste from face masks, but also to serve as a material that can be used by students, teachers, and anyone else who may need it. Its size is 8 by 11 inches with a durable look and feel. Faespher appears to be smooth but has a subtle roughness, making it a little rougher than smooth paper. The packaging used for the paper has a sleek black and white theme with two different types. The first one houses 500 sheets of paper, while the second type with an accessible design using a liftable cover holds 2,500 sheets of paper.
You know what? I just realized that disposable face masks are saving lives, but at the same time, ruining the environment.
Exactly. That is why we should be responsible on how we dispose these face masks and use our creativity and resources to upcycle these wastes safely.
I'm Ethan M. Katangal.
I am Nick Gabriel Gaza.
I am Katlea Jolene D.M. Carrion.
I am Liker Fanan.
I'm Kimmy Lee S. Watch. Alright, this is Anna Gabriel Donaire.
John Raven Alyanige.
And I am Aaron Duray T. Yumo presenting Faespher, a face mask scrap produced paper. This has been Group 2 of 12 Aristarchus. Thank you for listening and Godspeed.